In this module, we want to take a look at some advanced OO topics, such as inheritance and polymorphism, as well as what it means to overload a method and override a method. So let's take a look. In this module, we're going to focus on inheritance and some of the concepts that come with it, such as polymorphism, method overriding, and virtual method invocation. We'll also discuss method overloading. In addition, we'll learn how an object gets constructed when inheritance is involved, and we'll learn about the last two access modifiers, the default and the protected modifier. Let's suppose we have the following situation. We need an employee class that has name, salary, and birth date attributes, as well as a getDetails method. And we also need a manager class that has the same three attributes as the employee class, that is the name, salary, and birth date, and the same method called getDetails, but it also needs one additional attribute called department. Now there's two ways that we could go about creating these classes. We could create the employee class with those attributes in the getDetails method, and we could create a separate manager class with those duplicated attributes and method, as well as the one additional department attribute. Now that would be a lot of work and a lot of duplication. And if every time we had this situation crop up, we duplicated all of our code, we would have a lot of unnecessary duplication. But luckily for us, in an object-oriented program like Java, we have a way to avoid this duplication, and that is called inheritance. So let's see how that works. Click the Inheritance tab. In Inheritance, what we will do is we will create the employee class with the three attributes, name, salary, and birth date, and the getDetails method. And we will create that class just as we have created all of our other classes before. But then, in the manager class, since a manager is a form of employee, and it shares the attributes name, salary, birth date, and the getDetails method with the employee class, we will have the manager class inherit from the employee class. Or, what we say is extends from the employee class. Basically, the way that inheritance works is you will say that one class extends from another class. And that class will then inherit all of the attributes and all of the methods from the class that it is extending. So, as we can see in the right-hand edit window, we have our class called manager. And now we see the extends keyword and the employee class name. So our manager class extends the employee class. What this means is that the manager class now inherits the salary attribute, the name attribute, and the birth date attribute from the employee class, as well as the getDetails method. So it's as if those attributes and those methods from the employee class have also been defined in the manager class. And now what the manager class is going to do is extend on to the employee class by adding the department attribute. So, just to quickly reiterate, the employee class has three attributes, salary, name, and birth date, and one method called getDetails. The manager class now, since it extends from employee, has four attributes. It has the salary, the name, and the birth date that it got from the employee class, as well as the department attribute that it has defined in its own class definition. It also has one method called getDetails, which it inherited from the employee class. You can now see in our syntax window the updated syntax for declaring a class. As always, you begin with your optional modifiers, then you have the class keyword, and then the name of the class. And then after that, you can put the extends keyword followed by a class name of a class that you are extending off of or inheriting from. Then, as always, you have your left and right curly braces, which begin the class body. Now, in Java, you can only extend off of one class. Or in other words, you may only inherit from one class. This is called single inheritance. Some languages allow for multiple inheritance, but Java, in order to simplify things, only allows you single inheritance. Now this isn't as big a limitation as it may seem, because we have another thing called interfaces which fills the void and avoids many of the drawbacks of multiple inheritance. And we'll be talking about interfaces in a later module. As you can see in our diagram, when you employ inheritance in your class design, in your program, you will get a tree structure. The more abstract or general classes are at top, like the employee class, and the more specific classes are at the bottom of the tree, like director. Now, inheritance is also known as an is-a relationship. So a director is a manager, is an employee. Same thing for engineer and secretary. They both are employees as well. So, to look at an example here, if we were to take a look at the director and list out all of the attributes that a director has, we would have, starting at the bottom, car allowance, then department from the manager class, and then birth date, salary, and name from the employee class. So 5 attributes. The director would also have 2 methods, the increase allowance method and the get details method. So as you can see, inheritance can go through multiple levels. So when we talk of single inheritance, what we mean is that a class may only directly inherit from one other class, but it may indirectly inherit from multiple other classes up the class inheritance hierarchy. In an earlier module, we discussed packages and how they allow us to organize our classes. And now in this module, we have discussed inheritance. So it's time for us to revisit our access modifiers. Now in Java, there are a total of 4 of them. There is private, the default, protected, and public. So we are going to see how these various modifiers affect our access to the foo method in the A class. But first, let's talk about the relationships of these 4 classes to each other. Now, over in the alpha package, we have the A and B classes. Now, they are both in the same package called alpha. Over in the beta package, we have classes C and D. They are in a different package than the A and B classes. Now, the C class, however, inherits from the A class. That is what the arrow is denoting. So we want to see the access that these different classes have to the foo method in the A class, depending on which modifier we use. Now, the modifiers will act the same whether it's an attribute that we apply the modifier to or a method. In our example, we're just going to be applying it to a method, the foo method. So let's start with the private modifier. Click the word private in the table below. So you can see when we apply the private modifier to the foo method, the B class and the C class and the D class are restricted from accessing the foo method. If they attempt to, they are just bounced back. The only code that could call the foo method is the code in the A class itself, because foo is private to the A class. Let's try the default modifier. Now, the thing to remember is the default is not a keyword. The default access level is just the default level. So you don't use a keyword when you want to apply the default access level to a method or an attribute. So click the default word in the table below. So as you can see now, the B class has been granted access to the foo method. It is not rejected. But the C and D classes are still not allowed to access the foo method. And as always, the A class can also access the foo method. So with the default level, only classes inside the same package are allowed to access that method or that attribute. And since the B class is in the same package as the A class, the B class has access to the foo method. So let's try the protected modifier. Click the protected word down in the table below. Now the B and the C classes have access to the foo method, but the D class is still rejected. Now with the protected access modifier, classes in the same package can access that method, and classes in a different package that inherit from the class can also access those attributes or those methods marked protected. And since the C class inherits from the A class, it is allowed access. Let's try the public modifier. Now with the public modifier, the B class, the C class, and the D class may all access the foo method. Because with the public modifier, any other class may access that attribute or that method. It doesn't matter if the class is in the same package, a different package, or if it inherits from that class or not. As we discussed earlier in this module, when one class extends from another class, that class inherits the attributes and methods of the other class. Now sometimes those methods that the class inherits work as they should, but other times we would like to modify those methods. And when we want to modify those methods, what we do is we override them. We replace their operation with a different operation. So as you can see, we have our employee class from before and the getDetails method. And the manager class is extending from employee and adding on a department attribute. And it is also overriding the getDetails method that it has inherited. So what that means is that the manager class is providing its own getDetails method and replacing the one that it would otherwise have inherited. Now for a class to override a method that it has inherited, it must use the same name, return type, and argument list as the method that it is overriding. Also, the method may not be less accessible than the method it overrides. What this means is, if the method that you have inherited is public, for instance, you may not set the new method to protected, private, or the default, because that would be more restrictive and thus less accessible. So as you can see in our manager class, we have a method called getDetails, which returns a string and takes no arguments. This correctly matches the method getDetails from the employee class. Thus, the new getDetails method is overriding the one that it would have inherited, and it is replacing the behavior that it would have inherited with its own behavior. In the previous slide, the getDetails method in the manager class completely replaced the getDetails method from the employee class. But what if we don't want to completely replace the behavior that we have inherited, but instead we would rather extend upon it? We would like to use the behavior that we have inherited and then just add to it. This would be another example of good code reuse. So in this example, we would like to be able to still use the getDetails method from the employee class, but just add onto the string that it returns. So in the getDetails method in the manager class, we're going to call the getDetails method from the employee class and then concatenate on the department. But how do we go about calling the getDetails method in the employee class? Well, that is where we use the super keyword, which stands for superclass. And it allows us to call methods from our superclass that we have overridden in the current class. So as you can see in the getDetails method in the manager class, we are calling super.getDetails, which will call the employee's getDetails method to get the string that has the name and salary in it, and then we will concatenate on the department information. Now, when you use the super keyword to call a method that you have overridden in your class, that method does not have to be in the class that you have directly extended from. It could be in a class higher up the inheritance hierarchy, but that was inherited by the class that you are extending from. You cannot, however, use the super keyword to try to skip over a level of inheritance. So what this means is if the employee class has provided a getDetails method, and the employee class also had inherited from some other class that had a getDetails method, you could not skip the employee class's getDetails implementation and try to call the one above it. You may only call the one that you would have otherwise inherited if you had not overridden it. Now let's take a look at polymorphism. Now basically polymorphism means many forms or many shapes. Now what we do not mean is that an object can have many different shapes or change from one shape or form to another. Once an object in Java has been created as a certain type, it is always that type. What I mean by that is if we create a manager object, it is always a manager object. It does not change forms. It doesn't go from a manager object to an employee object to a customer object, etc. Once a manager object, always a manager object. But what we do mean is that an object reference variable can refer to many different types of objects as long as they meet a certain criteria. So let's take a look at that. In the first line of our code in our edit window, we are creating a manager object and assigning the reference to an employee variable called E. Now this is allowed because a manager is an employee. It has an inheritance relationship. The manager class extends from the employee class. And everything an employee object has, a manager object has as well. So there's an overlap because remember, a manager got all of those things from the employee class. So it's perfectly legal to assign a manager reference to an employee object reference variable. The reverse is not true. You could not create an employee object and assign its reference to a manager variable. That's because an employee object doesn't have everything that a manager object has. So as long as you're going up the inheritance hierarchy, you can assign a reference to an object lower in the hierarchy to a variable of a type that's higher in the hierarchy. So line number 1 is valid. Let's take a look at our second line of code. Here we are trying to use the E variable to reference the department attribute. Now, this is illegal. This is a compile time check. What this means is that at compile time, the compiler will check to see, does the employee class have a department attribute? Because E has been declared as type employee. And the employee class does not have a department attribute, so this is illegal. Now, many students look at the first line of code and say, but wait, I assigned a manager object to the employee variable, and the manager class has a department attribute. This is true, but the compiler doesn't look at that. It doesn't look at any lines of code preceding the line of code it's on. It just looks to see if the employee class has a department attribute, and it doesn't. So that's a compile time check. Now let's go to the next line of code, e.getDetails. Now here, we are using the E variable to call the getDetails method. Now the getDetails method has been declared at the employee level and then was overridden at the manager level. So the compiler will go ahead and check to see if there is a getDetails method in the employee class. And there is. So this passes. This one will not generate a compiler error. Now at runtime, however, when the code actually executes, what is going to occur is that the runtime environment will detect that the E variable actually holds a reference to a manager object and not an employee object, and will divert the call from going to the employee class to the manager class. This is polymorphic behavior, and this is what we call a virtual method invocation. The correct method is getting called at runtime. So at compile time, the compiler thought it would be calling the getDetails method in the employee class. But at runtime, the runtime environment redirects the call to the manager class. Now that we just saw that we may assign a reference to an object lower in an inheritance hierarchy to a variable declared higher in an inheritance hierarchy because of the ISA relationship between the classes, we may now create collections of objects that, one, either store objects of the exact same type, which would be called a homogeneous collection, such as an array of myDate objects, and we can also have collections of objects that store heterogeneous collections. That is, collections that hold references to different types of objects, but they all share a common base class. For instance, in our lower edit window, we are creating an array to hold employee references. But that array can not only hold references to employee objects, it can also hold references to manager objects, because a manager is an employee, and engineer objects, because engineers are also employees. This allows Java to be extremely flexible. We can create these heterogeneous collections of objects and pass them around very easily. And it also allows our programs to adapt more easily to new classes being added, because we don't have to change these array types or other collection types. For instance, if we added a new employee called secretary, we could store the secretary reference in the employee array with no changes necessary, because the employee array can hold any type of employee. Okay, if you're like any of my students, you're probably asking, why would I ever want to assign a manager reference to an employee reference variable? Well, let's take a look at this. Down in the lower edit window, we have a class called TaxService, and in there we have a method called findTaxRate. Now that findTaxRate method takes an employee reference. Now the beauty of polymorphism is that this will not just take references to employees, but it will also take references to manager objects and engineer objects and director objects. Any type of employee can be passed into that method. Now, something that isn't an employee, like a customer, well, that can't be passed inside. That will get rejected by the compiler. So great, I can pass different types of objects to this findTaxRate. Well, where does that get me? Well, it makes your program more flexible and adaptable. For instance, let's say later on, down the road, I add a secretary class. My findTaxRate method doesn't have to change. I can make a secretary that extends from employee and then pass secretaries into my findTaxRate method to calculate their tax rate. So that allows my program to adapt to new types of objects. Also, through polymorphism and method overriding, if I pass an object into this method, let's say that has a getDetails method, polymorphism will call the correct version of that getDetails method. So for instance, let's look at the example in the upper left-hand window. Here we're creating the tax service object, and we're also creating a manager object. And now we're going to pass the manager object into the find tax rate method. Now again, perfectly legal because managers are employees. Now let's say down in the find tax rate method, it makes a call to the getDetails method. Now, because of polymorphism, it will call the manager's getDetails, not the employee's version of the getDetails method. So we saw how this happens in an earlier slide through virtual method invocation. At compile time, the compiler would think that it's going to call the getDetails method in the employee class. But at runtime, through polymorphism, the manager's getDetails method will get called, which would be the correct implementation to execute. So if you have a method that has an argument that is a reference to a class that's higher up in the hierarchy, and you want to be able to determine at runtime what the underlying or lower level class type of that class is, you can use the instance of operator. Now we can see this in our example here in the edit window. We have a method called doSomething which accepts a reference to an employee object. But in the method itself, we want to determine if that employee is a manager or an engineer, because we need to do something if it's a manager and we need to do something else if it's an engineer. And any other type of employee will do some default processing. So with the instance of operator, we give it the reference that we have, that's the E variable, and then the class name that we want to compare it to see if it's of that type of class. So E instance of manager will return true if the E variable is referring to a manager object at runtime, or false if it's not. Same thing with the next if statement where we're checking to see if the reference is to an instance of engineer. Now in our previous slide where we assigned the manager reference to the employee reference variable, that was an implicit cast up the inheritance hierarchy. And that can be done automatically because a manager is an employee always, 100% of the time. Every single manager object is also an instance of an employee object. But there are times where we need to go back down the hierarchy. That is, we have stored in the employee reference a reference to a manager object, and we want to get it back out and into a manager reference variable. So in that case, we must do an explicit cast, a cast down the inheritance hierarchy. Now you have to be extremely careful when you do this because the object that's referred to must actually be of that type that you are casting to. So in our edit window, we see how to do this safely and correctly. We have our method called doSomething, which accepts a reference to any employee type. So that could be an engineer, a manager, a plain old employee, or some other type of employee not shown here like secretary. So the first thing you need to do is determine if the reference held in the reference variable is of type manager, for instance. So that is what we're doing with our if statement and the instance of operator. We first check to see if the reference stored in the E variable is an instance of manager. If it is, then we are explicitly casting the reference held in the E variable to a manager reference and storing it in the M variable. So this is an explicit cast. Now once we've done that, we can then access the methods and attributes that are specific to the manager class, such as getDepartment. we could not use the E variable directly to call any manager-specific functionality, such as getDepartment or, let's say, the department attribute. We saw that in an earlier slide where that was not allowed because that would be a compile time error. If you happen to do an explicit cast at runtime where the reference to the object that you're casting from is not of the type that you're casting to, you will get a runtime error, and it would be an invalid class cast exception. Earlier in this module, we discussed overriding methods. Now we're going to talk about overloading methods. Now with overloading methods, what you have are multiple methods in a class with the same name, but they have different argument lists. Either the types of arguments differ, or the number of arguments differ, or both. Now the return type doesn't matter. That isn't taken into consideration. So as you can see in our example, we have a class called printStream, which has 3 different println functions. The first one takes an integer, the second one takes a float, and the third one takes a string. Each of these methods will convert the data that has been input to it to a textual representation and print it out. So why would I want to use something like this? Well, there are situations where you want to allow your users, that is other programmers, to call your code and provide different types of input and then basically do the same thing but with different input to it. And you'd like those methods to have the same name. Prior to being able to overload methods, we would have had to have created 3 different methods with 3 different method names. For example, we might have had one function called printInteger.ln, another function called printFloat.ln, and another function called printString.ln, just to allow the different input. Now with method overloading, we do not have to do that. We can reuse the same name. Another use for method overloading is the ability to simulate optional arguments to a method. For instance, in our upper left-hand edit window, we have a class called statistics. Now the statistics class has 3 average methods. The first one takes 2 arguments, the second one 3 arguments, and the third one 4 arguments. So we are using method overloading. Now to an outside user of this class, it could seem that we only have one average method that takes either 2, 3, or 4 arguments to the method to average them up. They don't have to know that there are actually 3 average methods, because to them the last 2 arguments are basically optional, and at a minimum they only need 2. So we can see that down in our lower edit window. We have 2 calls to the average method on the stats class. One that's passing in 3 arguments and one that's passing on 4. So it's as if there is an optional argument. Now in the J2SE 5.0, we have a new way to implement optional argument lists when the arguments are all of the same type. We can see this notation in the upper right-hand edit window for our average method. We have an argument called nums of type int followed by 3 periods. This is indicating that any number of integers can be passed into the method. Those integers will then be combined into an array. Now, just like you can overload methods, you may also overload constructors. But as always, the number of arguments, the type of arguments, or both must be different between all versions of the constructor. And in addition to being able to overload constructors, you may also call one constructor from another constructor using the this call. So let's take a look at an example of this. Here we have the employee class. It has 4 overloaded constructors. The first one takes a name, salary, and date of birth. The second one, just a name and a salary. The third, a name and a date of birth. And the fourth, just a name. Now, if we take a look at the employee constructor that takes just a name, it calls the employee constructor that takes a name and a salary using the this call and passing in the name plus some base salary constant. That constructor, in turn, will call the first constructor, passing in the name and the salary, plus a null value for the date of birth. So you can see one constructor can call another constructor, which would call another constructor. But to do it again, you must use the this call, and the this call must be the first line in a constructor if it's going to use it. Now the third constructor takes in a name and date of birth, and it will also call the first constructor, passing in the name, a base salary constant, and the date of birth that it has been passed. Now the first constructor does all of the work, and so it has no this call because it's doing everything for all of the other ones. So you can see in this example, by using multiple overloaded constructors, we are allowing other programmers to create our employee objects, providing different input, and then we will provide the default input that is needed depending on which constructor is called. Now, unlike normal methods, constructors are not inherited. So each class must have at least one constructor of its own. Now that constructor would be provided by the compiler if we didn't specify one. Also, when one class extends from another class, both classes' constructors must be called. So for instance, if we have a class called manager which extends employee, when a manager object gets created, a constructor at the manager level must be executed and a constructor at the employee level must be executed. This is to make sure that all of the code at each of the class levels is properly initialized. Now this gets tricky when we have multiple constructors in our different classes. And what we must do is use the super call to tell the compiler which constructor we want executed at the level above us. So let's take a look at an example to help clarify this. So let's say we have a class called employee which has 4 different constructors. This is from our previous example. Now if we were to create an employee object directly through the new operator, we would say something like new employee Steve for the name, and then let's say a salary of $1 million. This would create an employee object using the second constructor in our class, the one that takes a string and a double. Now the choice of constructor in this case was obvious because we used the new operator and it could determine the correct constructor from the number and types of parameters supplied. But let's suppose we have a class called manager which extends employee. And let's say the manager class has 3 constructors. One that takes a name, a salary, and a department, one that takes just a name and a department, and one that just takes a department. Now once again, if we said that we wanted to create a new manager and supplied a string and a department for the constructor, then it would know exactly which manager constructor to call. That would be the second one. But the problem isn't which manager constructor to call, it's which employee constructor to call. Because remember, I said that a constructor at each level in the class hierarchy must be executed. So what we must do is tell the compiler which constructor we would like executed for the class above us by using the super command. And we can see that in our manager constructors. If we call the first manager constructor, the one that takes name, salary, and department, we are telling the compiler to call the constructor for the employee class that takes a name and a salary. This is the super call, and it must be the first line in your constructor. Now let's take a look at the second constructor for the manager class. It takes a name and a department, and it is telling the compiler through the super call to call the employee constructor that takes just a name. Now the third constructor has an error in it. It has not supplied a super call. So when a super call is not supplied, the compiler will default to a super call with no arguments in it. So what it will do is it will try to find a constructor in the class above, which is the employee class in our example, that takes no arguments. But the employee class doesn't have a constructor that takes no arguments, and thus we get an error message. So to reiterate, we use the super command to tell the compiler which constructor we wish to have executed for the class above us. And we use the this command to call from one constructor to another constructor within the same class. Now, one last thing. When objects are created, the constructors are always called from the topmost level constructor to the bottom constructor. So in our example here, the employee constructor would get executed first, and then the manager constructor. Now this is because in the manager class we may want to use some of the employee attributes or methods in our constructor, and therefore the employee object must have already been initialized for that to occur. So let's go ahead and walk through an example and see how an object gets created and all the constructors that can get called during the process. So in this example, we are going to create a new manager object. So we see in the lower right hand edit window, we see this line of code creating this manager object. In the upper right hand edit window, we see the manager class. And one thing that you may have noticed on some of the other slides, which we haven't yet talked about, is that we've been showing the employee class extending from a class called object. Now in Java, all classes extend from object. They either directly extend from it or indirectly extend from it through inheritance. So what happens is, if your class does not extend from another class, that is, your class declaration doesn't use the extends keyword, then your class is automatically extended by the compiler from the object class. Now if your class extends from some other class, then at some point through the inheritance hierarchy, your class will indirectly extend from object. So as we can see in our two edit windows, these two are equivalent. Now the second one you would not normally do. Now why would Java want all classes to extend from a class called object? Well, for one, as we saw before, that if you have a common base class, then you can create things like an array of that type and store all the subclasses in that array. And also, the object class has common methods that all classes inherit and that you know every class has, no matter who creates the class. So let's take a look at a couple of these methods. The first one is the equals method. Click the equals tab. Every class has an equals method because it inherits this from the object class. Now the default equals method that you inherit just compares the object reference values. So it's not a very useful equals method. So typically, if we want two of our objects to be able to be compared together and have the comparison based on some of our attributes or on some other criteria, we will override the equals method. We see this in the myDate class on the left. We have overridden the equals method. And inside of this equals method, we are comparing the day, month, and year attributes of this myDate object with the past and myDate objects' day, month, and year attributes. And if they are all equal, then we return true as our result. And if they are not, we return false, indicating that they are not equal myDate objects. Now, one rule that we have when we override the equals method is that we are supposed to override the hash code method as well. Now, the hash code method is a little bit more complicated to understand what its purpose is for, and we won't be going into that here. But the rule is that if two objects are equal, they must return the same hash code. It is not the same, though, to say that if two objects return the same hash code, that they are equal. This is a subtle but important point. So now let's go ahead and take a look at the test equals class on the right and see how this equals method is used. So we are creating two MyDate objects, both with the same date. The first if statement is the comparison that the default equals method that we inherit from the object class would perform. Now this, you can see, is not really doing what we would want. This isn't comparing the date attributes. It's just comparing the reference values. And this would not return true because they are not the same identical exact object. So what we need to do is override the equals method, which we have done, which will compare the internal attributes to see if the dates are equal. And then we use the equals method, as you see down in the second if statement. Now it doesn't matter if you ask the date1 object to compare itself to the date2 object, or if you reverse these and say date2 dot equals date1. You are just asking one of the objects if it's equal to the other object. Now let's take a look at the toString method, which is another method that we inherit. Now the toString method is used to convert your object to a string. Now the toString method that we inherit does just a basic conversion from the object to the string. So you will want to override the toString method if you want something more descriptive. For example, for the date object, we would probably concatenate the month, the day, and the year and return that string. Now, as we can see in our little example here, certain functions in Java take advantage of the fact that every object has a toString function. For instance, system.out.println in the top edit window can convert the date called a now into a string because it knows it can just call the toString method to do that. So the println statement in the upper window is equivalent to the println statement in the lower window. Also, with the plus operator, when it's used as the concatenation operation, will also convert an object to a string when it is needed. So if you take a string plus a reference to an object, the concatenation operator will automatically call the toString method on the object to convert it into a string and then do string concatenation. Now we already know that there are 8 primitive data types and that these primitive data types are not objects. But Java also provides us with what they call the wrapper classes, which are the object representation of the primitive data types. So for instance, for the Boolean primitive data type, we have a Boolean class. For the byte primitive data type, we also have a byte class. Now these wrapper classes allow you to store the primitive that is associated with that wrapper class inside of it. Because you see, sometimes we need to have an object instead of a primitive for that particular piece of data. This is particularly true when we get to collections. If we want to store a primitive value in a collection, we must first wrap it inside of an object because the collections can only manipulate object references. This is called boxing when we do this. We are basically boxing up the primitive and storing it into an object. And we can see this in our edit window. We are creating an integer primitive with a value of 420. We are then creating the integer wrapper class and storing that value 420 inside of it. So now we have an object reference to that integer. Now when we want to get that primitive value back out, we just ask for its int value and we will get the integer primitive. This is called unboxing. Now all of the different wrapper classes have a function to get the value out, and it follows the same pattern. So to get a short out of the short wrapper classes, you would use the short value method. To get a double value out of its wrapper class, you would use the double value method. Now, as of the J2SE 5.0, we also have auto boxing and auto unboxing, which we see on lines 4 and 5. In these instances, Java is automatically boxing the primitive value up into the wrapper class and automatically unboxing the primitive out of the wrapper class, so that we don't have to do the coding for it. But you want to be careful not to overdo this, because there is overhead when boxing and unboxing. Now, there are other methods on these wrapper classes that help us with other things like data conversion. And we see two examples of these. We see the static method called valueOf and the static method parseInt. So let's first take a look at the valueOf method. The valueOf method will take a string, and as long as the string is in the proper format for that wrapper class type, it will convert it into an instance of that wrapper class. So for instance, if our string was a string with the number 55 in it, it would convert that string into an integer wrapper class object with the value 55 in it. And then we could use the intValue method to get the primitive 55 out of that wrapper class. Now, if you want to go directly to the primitive without first going to the wrapper class, you could use the parseInt method, which will take a string and once again has to be in the correct format. So if the string was the number 55, the parseInt method would return us an int primitive of value 55. Now, if I tried to use these methods on a string that was not properly formatted, for instance on a string with the word Steve in it, I would get an exception generated. So you have to be careful when you use these functions that your strings are properly formatted. And we'll see how to use try-catch blocks later on that will help us handle this situation. In this module, we focused on inheritance, and along with it, the concepts of polymorphism and method overriding, as well as virtual method invocation. We also covered topics like method overloading, and we learned how constructors are used and how we can call one constructor from another with a this call and call up the constructor hierarchy with the super call. We also learned more about the access modifiers, in particular the protected and the default access levels.